After all the discussions of first-class functions and all these other features in JavaScript, we're ready to discuss one of my favorite topics when it comes to the JavaScript programming language. It's called functional programming. Although JavaScript sounds like it's related to the Java programming language and looks like the C++, C# Java languages a bit, it really has more in common in many ways with other languages called functional programming languages, languages like Lisp or Schema or ML. These are languages that have first-class functions, like we've talked about. Functions that behave as objects. You can pass them as parameters. You can return them from functions. And so having first-class functions in the JavaScript programming language means that we can implement what's called functional programming, where we think and code in terms of functions. This is one of my favorite topics because it introduces an entirely different way of thinking and implementing when programming. It introduces an approach that you simply can't do in other programming languages that don't have first-class functions. So let's take a look at some examples of the beauty of functional programming. We'll start with a simple array. I'll put a few numeric values in an array, and I'll just log it so that we can keep track of what we're doing. And let's suppose my task here is to create a new array out of this first array. So I need to loop over all of the items in the array. Let's say array1.length. There's a length property, how big it is, how long it is. And I'm going to use the push property, or the method, to, let's say, double each value in this first array. So I'm creating a second array that has each item double the value of its equivalent item in the first one. So I loop over each item, and I push a value that's times 2 of that. So I get 1, 2, 3, and then my new array is 2, 4, 6. So I had to write a lot of code to do that. And we know that as programmers, we want to always minimize how much work we're doing, how much typing we're doing, and how often we're repeating ourselves. So we tend to put things into functions in order to do that, to limit repetition. We put work into functions. But in programming languages where functions aren't first class, there is limitations to how much you can put into a function, to how granularly you can segment your code. However, with first class functions, we can do something entirely different. We can head toward functional programming. So let's say, for example, I create a new function. I'm going to call it map for each. It takes an array, and it takes a function. Remember, I'm using first-class functions, so I can pass a function object. Map simply means what we just did here. I'm going to take one array, do something to it, and get a new array out of it. So I'll create a very simple mapping function. I'll do very similarly to what I did below, and I'll even borrow this for loop here. I'll just change this to array. So I'm looping over whatever array is passed. I'm going to push to the new array. But here is where my functional programming comes in. I'm going to call a function and pass in that array item. And then this is going to return the new array. So do you see what I'm doing? I'm saying I'm going to create a new array, loop over the array you've given me, and add to that new array for every item in the one you gave me your array item, which is processed by some function that you also give me. So I've just abstracted the concept of iterating or looping over an array, creating a new array out of it and writing some function, whatever function you want to, against each item. take some action against each item. Pass this array item to the function, and this function should then return something that it does with that array item. And I'll add that to my new array. If I do that, then I can take all of this code here, and instead I can simply call map for each. I'll pass that first array to it, and then I'll create a function using a function expression. It needs to accept an item because that's what's going to be passed to it, so I'll just call it item. And then it needs to return and then do something to that item. Do you see what's happening here? Let's output this. Let's go ahead and run this. And I get the same results, a doubled array. But what I did was I took all of that code, all of that noise of the for loop and creating the new array, and I segmented that off into its own function, and then I gave it the work to do against each item in the array. This is very powerful. Think about this for a bit. Look at it. I called a function, gave it an array, and told it what to do to each item in the array. And then this function here is what's passed in. And that is what's called, what's invoked, as the function is looping across the array. That means that I could do something entirely different. Let's say I have a third array that I'm going to fill up, and I'll give it this initial 1, 2, 3 array. But I don't even have to do mathematical things with this. I could simply say, give me an array that matches up to this original, but instead tells me if an item is greater than 2. See that? I'm using the exact same map for each call, and I'm giving a different bit of work, and then returning a Boolean, in this case, true or false. So when I output this, I get false, false, true. 1 is not greater than 2. 2 is not greater than 2. 3 is greater than 2. So I get false, false, true. See that? I was able then to reuse this map for each to do entirely different work against the array simply by passing the function, passing the work that I wanted to get done against it. This is a classic example of functional programming, where I'm using first-class functions to my advantage to segment my code in even cleaner and tighter ways, and this lets me build really clean and in some ways beautiful looking code that's very straightforward to understand. So mess around with this. Try creating your own functions that you pass to the map for each, or create some other function that accepts a function that does work. Let's look at another example. Let's say, let me spread this out just a little bit. Let's say that I'm going to use my map for each to check if something is past a limit, just like here, but what if I want to make this 2 a variable that I pass in, so I can make this reusable? Well, I can do the creation of a new function, and maybe I'll pass my limiter, what it is that I want to say that it must be greater than or less than, and it'll accept the item as well because it's going to do work against each item in the array, and I'll return item is greater than the limiter. See that? So it's past whatever limit I pass to it. I'm just using a variable instead of directly hard coding a number right there. I'm saying check and see if this item is past a certain limit. All right. So how can I use this? Well, I have a bit of a problem. This function accepts 2 parameters, and the map for each wants a function that accepts just 1. So how can I take a function and call it, or use it in a way that I preset this parameter so that this function call up here, where it passes the item in my passed in array to the function, so that that gets passed to item, and that I preset this. Do you remember? So I can use bind. I could say I'll create another array, map for each, pass in that initial array, check pass limit, but I'll bind, well, the this keyword I don't need to worry about, so I'll just pass the whatever this keyword is right here, and I'll set 1. Remember that if I put parameters on the bind, it'll default that parameter or preset that parameter to that value for every subsequent function call. So I've just created a copy of this function on the fly with 1 as the limiter. So now I can just console.log the resulting array. So this should return false or true depending on if each item in the array is greater than 1. There it is. 1 is not greater than 1. 2 is greater than 1. 3 is greater than 1. Do you see that? That's my resulting array. Let's track what happened again. I created a function using a function expression that accepted some limiter that I'm checking against to see if my individual array items are higher than it. Accepts an item because we need to do work on each individual item, and it gives me back a Boolean. I then call map for each, and I pass the array. That's the array that it loops over. And I pass a function that I make a copy of it using bind. I just put this in there because it doesn't really matter. I'm not using the this keyword inside the function. And then I set this first parameter to a 1. So that when this map for each calls function and passes that array item will get passed into here because this is already a 1. The limiter is already a 1. So it will say, all right, is this array item greater than 1? And give me back true or false. And so it mapped 1, 2, 3 to false, true, true. And I could change this to a 2. And it becomes false, false, true. 2 is not greater than 2, so that becomes false. Make sense? And that's all in one line of code. But you might say, well, it's kind of annoying to call bind all the time. It'd be nice just to pass in my limiter as the only parameter. Can you think of a way to do that? Can we create a function where I only pass in the limiter and it gives me back a function like this? Give that a try. Pause the video. Try to figure out a way to wrap up this into a function that just takes the limiter, so that all I have to do is just call it and pass whatever my limiting value is, my top value, my value that I want to be right there. Pause the video and try that for yourself. See if you can come up with a function that will be even easier to use, so I don't have to call .bind manually all the time. All right, ready? I'm going to create, I'll call it check pass limit simplified. And it's going to just take the limiter. And since it's going to just take the limiter, I need to create a function that I created up here. So it's going to return a function object. So I have a function that returns a function. But I need it to have its initial value, its first parameter, preset. All right, let's take a look at this again. I have a function that takes the limiter. It itself returns the function that I'll actually use, limiter item, and then I use .bind to preset the limiter from what I was passed here. So when I run check passed limit simplified, it will execute and it will just give me back a function that had the bind called on it. Just like this here, essentially. Now, don't get confused by this limiter and this limiter here. This isn't getting passed to this. This function isn't being executed. It's simply creating the function object. I create it with a function expression, then copy that object that was created with bind with this limiter parameter preset to whatever the value is I passed into that outer function. So I'm creating an object. That's all I'm doing. I'm creating an object. And I'm using .bind to create an object that has its first parameter preset. So let's use this. I'll create yet another array, map for each past that first array that has 1, 2, 3, and I'll use check pass limit simplified, and I'll simply set my limiter. Let's log this. False, false, true. 1 is not greater than 2. 2 is not greater than 2. 3 is greater than 2. Let's change it. I'll just set a 1. 1 is not greater than 1. 2 is greater than 1. 3 is greater than 1. Do you see that? Do you see what's happening? I called this function, which returned a function object with its first parameter preset to this number, and that returned function object is what gets passed to the map for each, and then it gets called. And I get my new array back in one very clean, very simple line of code that I can reuse. I hope at this point, if you're taking a good look at this code and trying this for yourself, that you've come to begin to appreciate the power and expressiveness of functional programming. Instead of thinking purely in just separating your code into functions, you can start to think about how can I give my functions or return functions from my functions in order to even greater simplify the code that I'm writing over and over again. At first, it may feel like it's stretching your brain a little bit to have all these functions flying around. But once you get used to it, it's very natural feeling to split things into functions, to pass them around to each other, because you're just splitting up the work in even finer, more minute, granular details than you might in other programming languages. And this gives you an opportunity to really do some extraordinarily clean things. One other note about functional programming: your functions, especially the tiny ones, as you're moving and passing little functions around that do work, should do their best to not mutate data. Mutate, remember, means change. You can really find yourself in odd circumstances when you're actually changing data in these little tiny functions that you start to pass around as you're breaking things down in functional programming. So it's always better to mutate data, that is, change it as high up in that chain as possible of functions, or to not change it at all, instead return something new, like we're doing here with new arrays, as opposed to changing that core array that I passed in. That's just a side note about functional programming. Functional programming in itself could be an entire course, but I wanted to introduce you to this idea in JavaScript because I think this first-class functions and functional programming in JavaScript is really what takes JavaScript to the next level and will take you as a JavaScript programmer to the next level. Instead of simply using JavaScript the way that you use maybe other programming languages, like PHP or Java or C# or whatever, you can use the full power of the language that's available to you, that's not available in those other languages. All right, let's take a moment to talk about one of the most well-used and well-known examples of functional programming in JavaScript.